My name is Dudley Harris. I'm a student of ceramics at the Southwood School of Art in San Antonio, Texas. Behind me is kiln number 1. I have the privilege and honor to be able to fire this kiln, and I'm going to show on this video the way that I fire it. This kiln has 3 Venturi burners on each side. The controls for the burner are 2. There is a flow control, and then there is a valve to control the primary air, and then the secondary air goes in there. The damper is built between the kiln and the chimney, and the way I set up the kiln, I fire it with the damper completely open, but it's very important to pack the damper very well with the kiln wool so that there is no way for air to get into the kiln through this opening. You have to have that packed very, very tightly. Otherwise, if air can get in there, it functions as a damper. And in this kiln, we do not want anything that would over damper the kiln. The kiln and the front door, which is on hinges, has 3 spy holes. The spy hole in the bottom I have open, and there is a cone pack inside there, and watching that cone pack will tell me when to turn the kiln off. The middle spy hole, I have a pyrometer, and it's one of the fluky pyrometers which is very accurate, so that I can read in tenths of a degree and up to 1,000 degrees, and it very clearly tells me the rate of climb of the temperature, and rate of climb is very critical. The top spy hole I have plugged with kiln wool. I don't use the information that I might get from that spy hole. I would rather plug it up and keep and prevent heat loss from that spy hole. I find that it's not necessary to have a cone pack there, because this kiln fires so evenly that it's just not necessary. But the first thing I'm going to do is take a meter reading on the gas, because I think it's very interesting to see how much gas that we're actually using. This dial right here measures 1,000 cubic feet of gas. So if it goes from 0 to 1, that's 100 cubic feet of gas. And so we can measure about, say, an accuracy of about 10 cubic feet of gas. So that's a fairly accurate measurement. I'm going to start the kiln by lighting one pilot light. Now I'm going to light 2 more pilots. I'm going to light a total of 4 pilot lights, and I'm going to leave those burning overnight. That'll use about $1 worth of gas, and it will completely dry out the kiln. So in the morning, the kiln is going to be right around 200 degrees. If I burn 3 pilot lights, it will be below 200 degrees. If I burn 4 pilots all night long, it's going to be over 200 degrees, but that will be a very slow rise of temperature. Now I'm going to light the 4th burner. You may, 4 pilot lights are going. And you may say, well, why Why would you start so slowly? Because this is a glaze firing, not a bisque firing. Just let it go ahead and climb very rapidly. Since everything is already dry in the kiln, but everything's not already dry, because the clay balls that I use to put on the top of the stilts, between the stilt and the shelf, those are, that's still wet clay. And if the temperature rises too rapidly, then I worry that those clay balls will explode and get clay in my pieces. Since I've started firing this way, the problem that I had before has essentially really gone away. I have almost no loss of pots based on those getting clay particles in the pots. It's now 7 o'clock the next morning. The kiln has been burning for about 20 hours on 4 pilots. I've taken one measurement and the temperature is 240 degrees. So now I'm going to light the second 2 pilots and I'm going to light 1 burner. This is the pyrometer, and this is tenths of a degree, and this is 1 degree. This number should change about every 10 seconds, and that's 300 degrees an hour. So you can see that with 1 burner on, that it is climbing at 300 degrees an hour. And that's because the kiln is quite cold, so all of that energy is going to raising the temperature, and very little is going to holding the temperature. It's now 8 o'clock. You can see the temperature rise has slowed down, so 1 burner will bring up the temperature to about 415 degrees, but then it really tapers off. So now I'm going to light 1 more burner. It's now 8:30. Temperature is 583. You can see the temperature rise has slowed down a good bit, but in the past 30 minutes it did rise at 300 degrees an hour, which is this line right here. So I'm going to light 1 more burner. Okay, I lighted the 4th burner about 10 seconds ago, and you can see the temperature rise is much more rapid, although not quite as fast as when I lighted the very first burner. So a lot of the energy is now going to maintain this temperature of 730 degrees. It's now 9:30. Temperature is 825. Temperature rise is still climbing, and this is with 4 burners on low. Now I'm going to light another burner. It's now 10 o'clock. And 5 burners are on low. Temperature is 944. And the temperature rise is still going up pretty good, just with 4 burners on low. And it's tapered off a good bit, so I'm going to light the 6th and last burner, and I'm going to set the gas flow to 2 units of flow. Now all 6 burners are on 2 units of gas flow. You can see that the temperature rise is going up very well here. Now what I'm going to do is to experiment with setting the primary airflow valves, primary airflow valves. I have set all the valves at this aperture right here, and now what I'm going to do, I'm going to open them all the way, or almost all the way. And I'm going to do that on all 6. Now I have opened up the primary air valves all the way on all 6 burners. Gas flow is at 2. After we get to 1,000, we've lost our ability to see in tenths of a degree. So I'm going to count when it changes. 1, 2, 3, 4, 5, 6, so 6, it took about 6. We'll try it again. It changes. 1, 2, 3, 4, 5, 6. Okay, so about 6 seconds to go up a degree. Now I'm going to go and close the valves almost all the way down. I'm going to set the primary air valve to almost closed, about the width of a dime, and I'm going to do that to all of the air valves. Okay, I've now closed down the primary air valves on all 6 burners. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. Okay, so closing the primary air valves increases the speed of the kiln because their primary air valve lets in so much nitrogen, and that has to be heated up, and that energy goes to heating the nitrogen, not to heating the kiln. So the next question is, well, is the kiln burner getting enough air? And I can answer that by saying that I've made this measurement with the oxyprobe, and closing that primary air valve down to about the width of a quarter, or let's say a quarter, not a dime, but a quarter, that does not put the kiln into reduction if it's in oxidation right now. So it appears that that amount of air, that primary air, that setting on the primary air valve is sufficient provides sufficient air for the burner. It's now 10:30. Temperature is 1209, and the rate of temperature rise is a little better than 300 degrees an hour, and this is with all 6 burners set on a gas flow of 2 units. So there's no point in increasing the gas flow right now, since the temperature rise is exactly what we want. So in 30 minutes we'll check again. It'll probably start to taper off, and then we'll increase the gas a little more. It's now 11 o'clock. Temperature is 1341. Gas flow is on 2 units, and we're still rising at 300 degrees an hour, so there's no need to increase the gas at this point. We'll wait another 30 minutes. 11:30. Temperature is 1437, and the rate of climb has tapered off, so I'm going to increase the gas flow to 3 units of flow for each of the 6 burners. It's now 12 noon. Temperature is 1612. Rate of climb is 300 degrees an hour. So we're going to leave it alone for the time being. It's now 12:05. The temperature is 1660, and we start a body reduction at 1650. So the way I'm going to reduce is instead of closing the damper a little bit, I'm going to increase the gas, which is presently running at 3 units. I'm going to increase that to 4.5 units of flow, and that will be enough gas to put the kiln in reduction. Okay, 5 o'clock. Temperature got to 2330 according to the barometer, but cone 10 is flat and 11 is starting to bend slightly, so that went up very quickly. Actually, that's the fastest curve that I've ever had since I've been firing this kiln. So hopefully the reduction is satisfactory, and and we'll take a look at that when I open the kiln in a couple of days.